Welcome back, everyone. We're going to do part 3 of public health data and communications, focusing on the presentation of the data and then how it's perceived by our audience. So again, just showing you where you are in the unit. We're a little bit more than halfway through. So we're going to start with how we present public health data. And I think the book gives short shrift to this topic. You could do an entire course on this topic. And the book really focuses on how we use graphics to promote understanding of data and information, which is excellent and a really important piece of how we communicate data. But in terms of how we communicate health information on the broader sense, this is just a little tiny piece. But we have less than 3 weeks, so that will have to suffice. So promoting understanding with graphics, a graph or a chart can be immeasurably helpful in communicating information. So you all have now already seen the data tables that you can access to look at COVID data in Dunn County, in the state of Wisconsin, in different counties. There are lots of different places that you can go to get different data tables on this. But this table, when you look at it quickly, doesn't give you a lot of very useful information, right? You have to kind of read every column and then say what's happening here. And so this is where a graph or a chart can be really helpful. So here is a bar chart, and we're showing you here, this is from back in 2021, daily new cases in Dunn County by the day that they were reported. And so this is much more effective at conveying information very quickly. You can see that in the summertime in 2021, there weren't very many cases. And then, oh look, Stout went into session and we saw a whole bunch of cases. And if you look by age group, they were mostly college-age students. And then it kind of got a little bit better. And then things really took off again going into the winter of 21-22. That was the Delta wave. So this bar chart can be really helpful, but you notice there's a lot of variability from day to day. So sometimes you can lose the forest for the trees. And so a different approach would be to show a line graph. And so this is a line graph. Not only is it different because it's a line instead of bars, but it's also looking at the 7-day averages. So the state pretty quickly started putting out, okay, well, here's the 7-day average of the number of new cases reported on any given day. And it's easier to see the change over time because everything's kind of been smoothed out. So not only would we be interested in the number of cases we were seeing in Dunn County, but we'd of course also be interested in how that compared to other counties in our area. So here's a line graph looking at those 7-day averages of new cases by county. So Eau Claire is in blue. That's the solid line. My apologies if you don't see color. It's this upper one here. This dotted one, which is green, is Chippewa County. And then here is Dunn County. And you take a look at this and you think, well, gosh darn it, Dunn County did pretty well. We didn't have as many cases as the other counties. And now here's where I'm going to say beware. These are total numbers of new cases. Eau Claire County is more than twice as big as Dunn County, so of course they had more cases than we did. So what do we need to do? Well, we need to look at incidence rate, right? We need to look at the rate per the population. And if we look at number of cases per 100,000 people, we actually see a very different picture. And we see that Eau Claire now is one of the lower counties, and that Dunn County actually, in terms of the rate per population for its size, had more COVID-19 cases than the other area counties. So again, look at rate, make sure it's adjusted for the population. Line graphs can be really useful in lots of ways. So here's one that was published just this year in the New England Journal of Medicine, looking at causes of death in children and adolescents. So we're going to take a look at our y-axis here, and these are deaths per 100,000. So these happen to be people aged 1 through 19. That's how they defined it in this study. And it's an incidence rate. So it's adjusted for the population. That's good because there's different numbers of children depending on which date you're looking at. And they looked by year from 1999 all the way to 2020. And so we can see some really interesting things. We can see that the number of deaths from motor vehicle accidents has declined significantly, right? So like cut in half from 1999 till about 2012. And you might wonder, well, gosh, why did that happen? And there were actually a lot of laws and policies enacted during that time in terms of car seats, in terms of seat belts, in terms of children needing to ride in the back seat until a certain age. The back seat is statistically a much safer place to be. Also in terms of safety features that come automatically installed on our vehicles. So side curtain airbags, they didn't used to be standard. So lots of things that we have done that are beyond the control of the individual, right, that have significantly and positively impacted the health of children in our country. So we can also see a significant increase in firearm-related injuries. And so these are gun deaths. Some of them are accidental, some of them are suicide, but a good number of them are homicides, actually. And so we've seen a significant increase in gun violence or firearm-related injury in children. Part of this, of course, is the mass shootings, the terrible tragedies at Uvalde and Sandy Hook, but that's actually a really small number overall compared to the total number of deaths that occur from guns. We also see, here's something else we need to pay attention to, drug overdose and poisoning. So this is a variety of things. One, because as you know, we're seeing many more problems with drug addiction in working age adults. There are just more drugs around, and some of those working age adults have children who get into their stash and into their supply and accidentally overdose. Some of this is because of edibles, right? Gummies and things like that, where children think it's candy and it's not. So these are some things that we need to work on. So this line graph shows us how things are changing over time in ways that are really useful. It also shows that, for the first time, firearm-related injuries have exceeded motor vehicle crashes. And so it's like, oh, we need to shift our priorities perhaps a little bit here. So this is in children. This is a line graph from the United Kingdom looking at causes of death. And the reason I chose this one is because you can see that heart disease far and away was the major killer and still is of adult male-bodied people in the United Kingdom. And that has improved significantly over time, right? Over just 15 years, 14 years. Huge decrease. And this is the standardized rate per 100,000 male-bodied people. And then you see here this, so what's this one that's increasing? Well, that's dementia and Alzheimer's disease. And I like showing you this one because that's a disease of people who live a long time. And we all have to go somehow. And so if we're going to see fewer deaths from heart disease, we're going to see more deaths from diseases that affect us when we are very elderly. So this information is really useful, but just because something is going up doesn't mean that we necessarily need to do something about it. It might just be inevitable. Here's another example of how creating graphs and charts can be really useful. This is a table of incidence, numbers of cases of cancer in African American individuals in the United States in 2016. And there's good information here, and you could spend a lot of time kind of looking at it and thinking about the relationships and which ones are the biggest and which ones are the smallest, and they arranged them in that order, so that's helpful. But if we create a pie chart, that's even more effective at conveying this information. So we can see in female-bodied people, the #1 cancer in African American female-bodied people is breast cancer, followed by a distant second, so half as many lung cancer and then colorectal cancer. While for male-bodied people, prostate cancer, this one's also lung cancer, and colorectal cancer. So we can see the top 3, right? Lung cancer, colorectal cancer, and then either breast or prostate cancer, depending on what body type you have. So this is a really effective way to convey a lot of complicated information. So graphs are useful. Okay, so graphics can be really powerful, and they can also be misused. So they can sometimes intentionally, sometimes unintentionally. So we need to make sure that they are accurate and appropriate. I'm going to give you a few examples of what not to do. So first of all, here's an example of what not to do. This shows procedures done at Planned Parenthoods in the United States. And the two things that they're showing here are abortions with the red line and cancer screening and prevention services with the pink line. So this is a very inaccurate way to convey information. They probably did it on purpose. This graph came from an anti-abortion group, so they wanted to bring people's attention to the fact that abortions were going up and make people really jazzed up about that. And so what I want you to do is take a look at the data here and see if you can see what the error is and in what way it is giving a false impression. So you can pause. I'm going to give you a hint. Look at the axes, look at the data, look at the numbers. And so you might have figured out by now that for the cancer screening, this is 2 million and it went down to 1 million. Abortions, 300,000, right? So a little less than 300,000 to a little more than 300,000. These two lines should not cross each other. These two things are completely on a different scale. So let me show you what it would look like if you did it on an appropriate axis. Aha. So there are several other things in this, but we can see here cancer screening and prevention services did go down during the time specified. But if we look at abortions, yes, there is an increase, but it's a relatively small increase that happened over that period of time. So the chart on the right gives a very misleading perception that all of a sudden they're doing more abortions than they are doing cancer screenings, which is just not true at all. You may wonder, why are they doing fewer cancer screening and prevention services? Yes, I know. And the reason is, sorry, my cat's meowing, is because the guidelines for pap smears, which are the #1 cancer screening that Planned Parenthood does, changed from you should do them every year to you should do them every 3 years. So they should have dropped by a third, and they did. So that's actually an appropriate change that we saw. So be careful. Be a discerning consumer of graphic information. I'm going to show you another one. And this one also has to do with abortion. We find a lot of these when it comes to abortion because it's something that people feel really passionate about. And so sometimes they're a little less careful or a little bit more willing to kind of bend the rules a little bit to make a case. And so what we're looking at here is two different things on line graphs. The first one is birth rate. So this is how many people are born, how many births per 1,000 women in what we would anticipate to be reproductive range. That's usually the statistic we look at. So in 1969, the birth rate was quite high, and then it dropped significantly, and then it stayed kind of about the same and then dropped a little bit. And this chart only goes up to 2014. And then they looked at the number of abortions that are reported. And we can see during the same time a huge increase, and then it's kind of tailed off. And it actually has continued to decrease since then for a lot of reasons. So this graph makes it obvious to someone that because there are way more abortions being done, that's why fewer babies are being born. But there are a lot of problems actually with this graph. And so you have to be kind of nuanced. So let's look at some of the issues. So one thing that they did, which is a good strategy, is they used rates instead of absolute numbers, right? So they looked at the rate per 1,000 people of that age. So that's a plus, that's well done. But a few cons. One is they're using two different axes, okay? So like we saw before, here's the birth rate over here, and here's the abortion rate over here, okay? Now, so this is, 3 times as high. So these should not be overlapping. They should not be crossing like that, kind of like what we saw before. Another con is that it gives the implication that abortions alone are the reason for the change in birth rate. There's a couple of problems with this. One is that over this time period here, is when birth control first came on the market in the United States and then became legal for use throughout the United States. So birth control was first approved in 1960, but it was highly restricted. You could only use it if you were married and if your husband agreed that you could use it. And then over the course of the next 10 to 15 years, laws and things were changed so that anyone could access birth control. So public health experts agree that the biggest influence on the change in the birth rate that occurred from the 60s into the mid-70s was the availability of birth control or contraception, which makes sense. The other problem with this graph is that until some states allowed abortion in the late 60s, and until the Supreme Court in 1973 said abortion had to be legal, we didn't have statistics on abortion. So it is not true that in 1969 the abortion rate was 0. But it is true that in 1969, because abortion was illegal in most places in the United States, we didn't have any data on it. Nobody's going to say, hey, guess what? I had an abortion. Yes, put me on the list. We didn't have any ability to capture these statistics. So we don't know how many abortions were happening in 1969 or 1970. We have no idea, actually. Did they become more common after it was made legal? Perhaps, probably. By this large of a factor, did they go from 0 to 30 per 1,000? No, they were definitely happening before that. If you talk with public health experts or people who were practicing medicine at the time, not me, I'm not that old, then they were definitely having women coming in with botched home abortions and all kinds of things. So abortions were happening. We just didn't have the ability to collect statistics. So be wary, okay? Be wary of graphs that tell a very powerful story that may not be fully accurate. So I just wanted to show you an example of another type of graph. So this one is a combination graph. So we have both a line and a bar graph. And we have two different axes here, right? So on the purple are people who are hospitalized with COVID-19. This was during the Delta wave in 2021. And then the orange line is the total number of cases. So people that were reported to have been diagnosed with COVID-19, to have tested positive for COVID-19. So again, these are raw numbers in this case, but they're from the same place, Dunn County. So that's all right. It's the same population for both. And so you can see that we can use a line graph and a bar graph together to help tell a story that yes, when there are more cases, in general, we see more hospitalizations. All right, the next section in the textbook talks about checking for quality. And so I've just spent some time showing you some things to look out for in graphs and charts. And then there's some information in the textbook about checking a website to see if it's a reliable source of information. You probably, hopefully, know a lot of this information already, so I'm just going to refer you back to the textbook on that. I'm also going to say, be wary of whether someone is trying to sell you something. So that is the thing that I often find folks of kind of Generation Z and even millennials sometimes are not keyed in on, is if the person that is presenting this information to you is trying to sell you something, either a product, which is often the case, especially for health-related things, or an idea, right? As we saw, with regard to the abortion graphs we saw earlier. So be careful of whether somebody is trying to sell you something. Yes. All right, so our next section in this unit is perception of health information. So we just talked about ways that we can present data that will be powerful and effective in helping people understand the data. But now what do we know about how people actually end up perceiving that information, right? How does it get received? How do they understand it? How do they internalize it? And so we actually know quite a bit about risk perception. So this is, for example, how do people perceive the risk of COVID? Are they likely to get it? Are they likely to get very sick from it or not? We were all making these calculations for the past 3 years on a regular basis. And what steps do we need to take to ameliorate or modify our risk or not? So there's actually a bit of science in the study of risk perception, and there are a few things that are specific to the hazard or potential risk itself, such as dread, and whether it's unfamiliar to us, or they use unknown here, or familiar to us. Then there are characteristics of the person themselves, right, who is perceiving the risk. So how old are they? What racial or ethnic groups are they a part of? What's their overall level of knowledge and understanding, right? So how educated are they about, in this case, health in general? What are their values, right? So remember, we've talked about personal liberty versus the good of all, right? How do we balance those things, and where do they land on kind of what values they ascribe to? Their own psychological traits. So some people are just really risk averse. They just rather not take a risk. They'd rather go with something that's sure and steady. Some people love to take risks, right? You know people like this. And then optimism bias. So in general, most people tend to think things are going to be okay and that bad things aren't going to happen to them. And statistically, they're often right, but sometimes we're biased in a way that's not reflective of reality. And then there's some heuristics. So these are kind of general cultural things. How available is something? Is it easy to modify your behavior or not? This idea that natural is better is very pervasive in our culture, especially in certain subgroups or subcommunities of our culture. And then trust, in terms of how much do you trust the systems in general? How much do you trust the messenger that is giving you the information? Lots of different things. So we're going to talk about a few of these in more detail. Dread. So this is a big one. People are really afraid of sharks, right? And in fact, the guy who made the movie Jaws now has said that he regrets it because he made people so terrified of sharks. So people tend to be really scared of sharks. It's very dramatic if there's a shark attack. It's very terrifying, this idea of something's lurking in the deep of the ocean that could just snap your leg off, right? But when we look at, is that rational to be very afraid of sharks? It turns out that sharks are a very, very low risk phenomenon. So shark attacks. So these are deaths in Australia. Australia is a place where people die from shark attacks. This was between 2000 and 2016. There were a total of 26 deaths due to shark attacks. Now that's not zero. They do happen, but they're really uncommon. People are often also really worried about bee sting allergies, right? And again, 27 during that entire time. So really small. Horseback riding injuries, 74. People who died from burns of various sorts, mostly from house fires. And then look at drowning. So if we're thinking about swimming related risks, drowning is much more likely to happen to you than being the victim of a shark attack. But yet there's not the same level of dread associated with it for the most part. So we perceive that risk very differently. Similarly, I grew up in the 70s, and we were all really worried about nuclear weapon attacks and the atomic bomb. And we had air raid drills in school and all kinds of things. So we were very worried about nuclear weapons. And I'm not saying this was still in the days of the Cold War, so it's not entirely impossible, but of course it didn't happen. And yet at the same time, we were riding in the backs of station wagons with no seatbelts, no anything. This is actually an ad from a picture from a car ad from the 1970s, and it says the rear of the wagon is a play area, right? So we had children who weren't in car seats, who weren't in seatbelts, and so we had many more deaths associated with that than we did with the atomic bomb, but we weren't worried about it. Okay, so dread. Another factor is familiarity. We all drive in cars all the time, at least most of us in this part of our country. We drive in cars all the time, probably every day, multiple times a day. We're very familiar with cars. So we are not afraid of cars, even though cars are more likely to kill us than something with which we are much less familiar, which is airplanes. So remembering the 70s, this is from the movie Airplane. In the 70s, she says nervous because they're on a plane, and he says, yes, very. She says first time, he says, no, I've been nervous lots of times. It's a silly movie. All right, so we tend to be more afraid of plane flights than we are of car rides because we are less familiar, most of us, with plane flights. But plane flights are actually safer. So you can look at a whole variety of things that people are afraid of. So again, no unknown and unfamiliar things and high dread things like nuclear weapons, nuclear reactor accidents, radioactive waste, right? All of these things are things that people are very worried about, whereas things that don't have a high sense of dread and are very familiar to us, like bicycles and motorcycles and skiing, we're not so worried about those things. And this is just part of human nature. This is part of how our brains and our psychology work. The unfortunate truth is it gives us a very skewed sense of what things are actually health risks to us and which things are not. So if you actually look at the data, if you look at how safe it is to fly on a commercial airline, it is extremely safe, okay? So your chance of dying in 1,000 hours of flying on commercial airplane flights is 0.01%. Whereas your chance of death in 1,000 hours of driving a car is 0.04%. So driving a car is 4 times as dangerous as flying in a plane. Riding a bike is 8 times as dangerous. We see 8 times as many deaths per the same number of hours of activity for cycling as we do for flying commercial airlines. And then you can see skiing is 7 times as dangerous. Here's some other things. Open water swimming. So swimming in a lake or an ocean is 31 times as dangerous as flying on a commercial airline, right? Marathon running 17 times is dangerous. We just don't tend to spend a lot of hours running marathons. Well, I know I don't. If you're really interested in seeing what are the really dangerous things, so motorcycles, they're 100 times more dangerous, more likely to cause death per hour of activity than flying on a commercial airline. Downhill mountain biking, even more dangerous than riding a motorcycle, interestingly. And then here's like ridiculously dangerous things, right? Like climbing Mount Everest, base jumping. Look at that. Death in the next 1,000 hours, more than 99%, right? That's just ridiculous. So our sense of what is risky is often very out of proportion and inaccurate. A couple of other factors that are involved is control. So if you have control over the situation, you tend to feel less at risk. And we all know this because when we are driving, we often feel just fine with it. But sometimes when somebody else is driving, we don't feel so fine with it. So the ability to be in control also impacts our sense of risk. And finally, large numbers. So we tend to be really bad at understanding large numbers. So once numbers get really big, we're just So to give you a sense, so Jeff Bezos is worth, about $200 or so billion. Okay, that means he makes about $150,000 every minute, right? What would be a really good salary for most people for a year, like a really good salary, he makes every minute. Right? This is mind-boggling. Or this one, right? If you worked every single day making $5,000 a day, which is an insane amount of money, right? Most people are lucky if they make that much a month, right? A day from the time Columbus sailed to America, 1492, to now, you would still not have $1 billion, right? Let alone $200 billion, right? And you would still have less money than Bezos makes in a week. Right? So we are really bad at understanding large numbers. So we've already talked about this a little bit in regard to COVID and how, a 0.3 or 0.6 mortality rate didn't sound all that bad. But when millions and millions and hundreds of millions of people are being infected with COVID, then we have millions of people dying. So a small percentage of a large number is still a very large number. And we tend to be bad at large numbers. So all of these reasons are why we need data and experts, right? So as individuals, as human beings, due to our nature, our sense of risk is impacted by, our sense of control, familiarity, amount of dread, all types of things that do not actually give us an accurate picture of what the true risk is. So this is why we need data to tell us, because our internal sense is like off, and experts who can look at that data and tell us, okay, well, in terms of morbidity and mortality, these are actually the things you need to worry about, not these other things, okay? So data is important. Experts who can interpret the data and help us understand it, super duper important. So So far, we have talked about where data comes from, the 7 S's, ways to measure the health of the population in terms of infant and child mortality rates, life expectancy, health-adjusted life expectancy, and disability-adjusted life years, how we present health information with lots of different graphics to make data understandable and making sure that those are accurate and appropriate, and then how people perceive health information based on our psychology as humans, factors of dread, familiarity, control, problems with large numbers, all those things, which is why we need data and experts. And in the next part, last part, we'll talk about how we combine all this information together and the different models we have for healthcare decision making.